defending against cloud cross-tenant vulnerabilities. So before we kick off, two quick announcements. The first is we are aware of the AC issues. So we are asking people to move towards the front where the AC is, front of the building where the AC is a little bit better, because that's where it's worst. But we're hoping to get it fixed in a little bit. Second, as always, like to thank our sponsors, especially our silver sponsor, ClearVector. ClearVector helps you prepare for, detect, investigate, and stop threats in your AWS environment. A real-time, identity-driven approach enables you to quickly figure out who did it and take action. Get started today with a free real-time risk assessment of your AWS environment. So, for those in the room, as always, please silence your cell phones, wave me over for the mic to ask questions, or ask them on Slack. Please welcome Tzah and Yanir. Thank you.
Thank you. Okay, so my name is Tzah Pahima.
My name is Yanir Tsarimi.
And we're going to talk about cross-tenant vulnerabilities, but we're going to take a spin on it. So most of you probably know what cross-tenant vulnerabilities are, especially after the last lecture, very good lecture by Nir and Sagi Tzaddik. And we're going to talk about it from a defensive side, which is a side that hasn't been really discussed up to now yet. So we're going to talk about two case studies from vulnerabilities that we found, both in Azure, actually. And then we're going to talk about how they could have been prevented and how you, as a security practitioner, as a cloud customer, could defend from these sort of vulnerabilities to the extent of your ability. So I'll give Yanir to introduce the first case study.
Hello, everyone. So I'm going to talk about AutoWarp. AutoWarp was a vulnerability in the Azure Automation Service. It was a high-impact vulnerability that I've discovered last December, and it was really, really simple. The vulnerability took like 2 hours to discover, if you guys read my blog, and the simplicity and the beauty in this exploit is, of course, how fast I found it and how simple it was to exploit. So let's get into what is the Azure Automation Services. So the Azure Automation Service is basically a managed service for uploading and executing your Python or PowerShell code. And it's very simple. Just like the last talk, managed services are easier to attack. So by default, you will execute your code in a shared sandbox environment, which means you will run your automation code inside a virtual machine, but isolated from other customers. Also, you have the option to use hybrid runbook workers, which is basically a feature to move your automation execution from the shared sandbox into a virtual machine that is owned under your account. And the service also has a feature for managed identities. So what exactly are managed identities and why do we need them? So automation scripts might need to interact with other Azure resources. What Azure resources will you need to access? Let's say, for example, you need to upload some data to your storage account, so you will need a managed identity. A managed identity is basically a token. It's a token to interact with the Azure API. You will receive the token and send it to Azure API, and you will be authenticated with that managed identity and have the permissions you've set under your configuration. So what is the way, how do we get that token actually inside the automation code? So as you can see here, this is some log lines that I've seen during my research. So when I approached this research, I started looking inside the sandbox, the shared sandbox, which is the default way to execute our code. And when I was looking through the service, I wasn't really aware about the managed identities in the service. I was just getting started. I think like 1 hour into my research, I was looking through the file system in the sandbox, and I was looking in some file, and I saw this log line. And in this log line, you can see that a new web server is set up. This is a web server that is local, and it has a strange port, 40,008, which immediately raised my suspicions. I was thinking, why 40,008? And when I was executing new jobs each time, the port changed, which really also raised my suspicions. So how do you get the token? You simply make a request inside the shared sandbox. just like you would make a request to the metadata service with the header of the metadata, and you will get back the token, and then you can interact with the API. So let's talk a little bit about that port number. Why is it 4008, and why was it changing? So that was my question during the research, and I found that that port is actually being assigned randomly because other ports are being taken by other customers on that virtual machine, obviously. So I was thinking, okay, what if I can access that port of other customers? It seemed very obvious to me at the time that it might be a problem, but I didn't think it would really work. So I set up an automation job, and I used Python to actually make requests from port 40,000 and up to all ports on the local machine. And I executed this actual code when I was doing my research, and the output that I was receiving is actually tokens of other customers inside the automation virtual machine. So when I was taking those tokens and I decoded them, I've seen that actually they belong to other tenants, and they hold permissions of managed identities that belong to other tenants. At this point, I stopped, and I immediately reported this issue to Microsoft. And this thing was very critical, and also was very surprising to me about how easy it was to get to this point from the point that I started researching. So let's talk a little bit about what are the problems here, and how can we actually work to defend against them. So the first problem is the obvious problem. It's the flawed sandbox. It's the environment that is vulnerable by itself. It's the vulnerability. So how do we actually would be able to defend from that is using the automation hybrid runbook workers, which is the feature that automations offers to move your workload to your own virtual machine. If you will be running in your own virtual machine, you will not be vulnerable to this type of vulnerability. The next problem, which is actually a feature, is managed identities allow access to other Azure resources, but when you think about it, you need the managed identity, but if you don't need it, you can simply disable it. And if you disable that, I will not be able to receive any token for your account, and this will not be a problem. But if you need to use it, obviously sometimes you will need to apply the concept of least privilege. If you apply the concept of least privilege and you assign minimal permissions, it's less likely that an attacker could make a big harm to your account. It's best if you also always apply the concept of least privilege and have your account as secure as possible. Right now, this is the case study for AutoOp, and let's move on to the next one.
Okay, so the next case we're going to talk about is a vulnerability called Synapse, which we found in the Azure Synapse Analytics service, and also has to do with the improper sandbox isolation between customers, and the kind of disastrous effects that it had is that we could obtain stored credentials, plain stored credentials of other customers, as well as their managed identities, so we can access the resources inside of their Azure account. To understand this vulnerability, we first need to understand what is the Azure Synapse Analytics service, and as its name suggests, it's an analytics service, right? It supports data integration from multiple different data sources. You can store your data, you can do analytics on big and really big amount of data, and the pipeline looks a little bit like this. You input from wherever you want. It could be an on-premise data source. It could be from the cloud, wherever you want. Then you use Azure Synapse Analytics to process that data. You can query it with an SQL syntax. You can use different runtimes to process it. And then you output it to view it either way you want. Now, when we approach research, we first try to understand how a customer might use it, and then we want to understand how we can exploit different behaviors. So the first thing we need to do is focus on the left side, which is, okay, let's see how we can import data in Azure Synapse. There's a feature called linked services. When you go to the user interface, it's pretty simple. You just click on new, and you select what kind of data source you want to connect to. So say you click on new, you want to connect to a MySQL server, you need to input the IP address of that server, you need to input the database name, table name, and you need to input your credentials. Makes sense. Another thing you need to input is a thing called integration runtime. What is exactly an integration runtime? It's just an endpoint, right? A compute infrastructure. It's used also by Synapse and Data Factory. And it's just the endpoint that's going to connect and import the data that you just assigned the credentials to, right? The MySQL server is going to be connected by this endpoint. You generally have two main types and a certain defense. So the default type is the Azure Integration Runtime. It's considered serverless. It's shared between customers. You just click next, next. That's it. It's set up. You can connect to wherever you want. You can add a defense mechanism on it called Managed Virtual Network, which kind of isolates you from other customers. And the third type, and the last one, is the self-hosted integration runtime. And as its name suggests, it's a self-hosted integration runtime. This means that as a researcher, if I want to understand how integration runtimes work, I can use it to start my research. So the fun thing is, it's a locally installed software, so you just download a package from Microsoft, you install it on your Windows computer, and it can be on-premise. Why would that be a feature? Because sometimes I have a MySQL server, for example, inside of my private network, which is not in the cloud. And if I want to import data from that private network to the cloud, makes sense. I can install the self-hosted integration runtime and connect it. It has over 95 connectors to different data sources. This is how it looks in the user interface, pretty basic. Self-hosted node is connected to the cloud service. Okay, so we talked about the fact that it has over 95 connectors. As a researcher, all we need is one weak link to try and get inside. So one of the connectors, if you want to read into the vulnerability itself, we have it in our blog. One of the connectors was vulnerable to remote code execution, specifically a shell injection. This means we tell it to connect to a specific server. We give it some properties, for example, the password, the username, and one of the fields was vulnerable to a shell injection, meaning we can just execute code on that integration runtime. But shouldn't be that interesting, right? Because it's a self-hosted integration runtime. I host it. It's my virtual machine. Doesn't really make sense that I want to execute code on myself, but we talked about the self-hosted integration runtime, and the shared integration runtime probably hosts multiple customers. If I want to escalate it, and they both support the same amount of connectors and the same features, I could just take the same exact data source, add it to the shared integration runtime, and the RC simply works. Let's talk about what we found inside of that shared integration runtime. So first things first, there should be a sandbox in place, right? Should be different customers, should be isolated. People are starting to giggle, I'm not sure why. Guys, this is the cloud. Okay, who am I? Anti-authority system. So this is a good start, right? Basically, for our Linux fellows, system, root, we can do whatever we want. Very nice. Now, the first thing we did, we said, okay, let's take a memory dump of the process that we are now inside and see what do we have in here, what environment are we running in. And we took a memory dump and we found plain credentials and plain API tokens for different customers, different tenants. This one is specifically actually a token, again, obviously censored, for Azure themselves, Microsoft themselves. This is one of their tokens. So easy stuff up to now. We have access to other tenants' data, right? But this is only by accident because I'm running on the same instance. I took a memory dump. That's okay. We also found a file, which is a client certificate. This led us to an internal management server. You can guess what an internal management server allowed us to do. So first things first, it allowed us to query other customers' workspaces in Synapse. It allowed us to access other customers' integration runtime, and it allowed us to tell their integration runtime to connect to whatever data source I want. And if you remember when I told you we have a remote code execution in one of the connectors, and now we can tell any integration runtime by any customer to connect to my own data source, if we combine both of these abilities, this means we have an RC on every integration runtime owned by every customer, and it can look a little bit like this when you're trying to leak credentials. The victim innocently just adds a linked service, adds the credentials to whatever he needs, and the attacker simply runs this Python script called workspace takeover. He can query the Synapse workspace. He chooses what credentials he wants to leak, and the script contacts the API server, contacts the integration runtime via the API server, runs code on that integration runtime, took some memory dump, and leaks the plain password as is. Okay. Also, managed identities. We've talked about them. You can query via the API server. Just take the managed identity, get a token for other Azure accounts, and you can decide what resource. If you take, for example, for the dev Azure Synapse domain, you have full control of the workspace. You can delete his resources. You can do whatever you want. You can also do it for the management, whatever, for storage, and then you get access. Whatever access is given to that Synapse workspace, you can do as an attacker. Quite bad. But let's talk about kind of the weak points and what you could do as a practitioner to defend yourself to the best of the ability. First things first, plainly stored credentials, that's already a problem. But this doesn't really have a solution in the sense that your endpoint still has to connect to your database, for example. And if it has to connect, it has credentials. There is no ultimate solution, but I would say that either using Azure Key Vault for monitoring access to your credentials, or using a passwordless solution could be a nice solution, because when you're not using Synapse, you could just disable that service. And now an attacker, comes up at 2 a.m., right, runs code on your instance, and your instance shouldn't connect at 2 a.m. to your database, for example, then you can simply use a passwordless solution to monitor or disable it when you're not using it. The second thing, also managed identities, right? We can get a token, we can access your account as the Synapse workspace, and here you can't really disable them. It's not a feature as it is in the Azure Automation Service, but you still can apply the concept of list privilege. Only give the minimum amount of privileges that you need to the minimum amount of resources that you absolutely need to make sure Synapse works for you. And the third thing is we just have remote code execution on your virtual machines, right, on your integration runtimes, and we can leak whatever data you process. This is just by design, right? There really is no good solution to this, aside from not having remote code executions, but when you have over 95 connectors, that's really not a possibility. So the best solution is just remove extra sensitive workloads from managed runtimes, right? If your runtime connects to a control plane API server by Azure, you might not want to process extra sensitive data on it. So I'll hand the mic back to Yanir to introduce some conclusions.
Okay, so we've talked about 2 case studies that are very specific to the vulnerabilities we've discovered. But right now we want to talk about the bigger picture, what we think is the bigger underlying issue here. So obviously, managed services and identities are an easier target. Just like the previous talk where they discussed managed services, when you have a managed service, it's easier to consider how you could move laterally from your own database, for example, and try to either attack the control plane or try to look around in the network like I did in AutoWarp. So this is really something to consider when you choose a service. For example, if you used like a service like EC2 to run your automation code, it would be much harder for someone to move laterally inside EC2. So for the next point.
The next point is minimizing privileges, right? The concept of list privilege. It works. It does help. It doesn't protect you entirely in all cases. For example, we saw the remote code execution on other integration runtimes. This wouldn't protect you. If you have sensitive data there, we can reach it. But a lot of times, if you do minimize the amount of privileges you give, for example, to a managed identity, you can be a lot less compromised. And
so the last point is, let's be real. In the end of the day, security is mostly up to your cloud provider. We've provided some specific solutions, but you can't really know about those vulnerabilities before we tell you about them. So you will need to actually trust your cloud provider to have the best security as possible and implement it as such. And this is it for today. Thank you so much. And if you have any questions, we're here.
Thanks. So my first question is, at any point did the cloud providers spot you or reach out to you as you were doing this analysis?
Okay, so this is actually a funny story. I'll tell you shortly. Not in these cases, but we did have one case. It was actually in Azure, but I won't say the service specifically, where I got a call, I think it was like 5:30 a.m. From, I think it was our CISO, saying, you know, this company reached out to us. They're saying, why are you brute forcing our servers? And actually, this was the only day I didn't bring my laptop home. So it really was an operation just to disable that script. But most of the time, when you're not too alarming, it's really hard to, you know, when you pinpoint specific services, it's really hard to track you.
Is there anything that cloud providers should be doing to make this easier? So making sure that managed identities are creating visible logs, or when a new connector is established, like forcing people to allow list them or something? I'm trying to think, like, what are some indicators of compromise that we could be monitoring as defenders, or if cloud providers gave us data?
So obviously you have some log features that you could look at right now. This is like, I've thought about it, and I think this is like the best case scenario is to just monitor what your managed identities are doing and what is being accessed to the best of your ability. But you will need to consider that if someone compromises a managed identity, in order to avoid being logged, they will also need to compromise the logging aspect of the cloud provider, which is, I think, a little bit harder, and it's also another step.
Cool. One more question I have, which is, many of us have to justify the use of any service to a third-party risk team or our compliance people. So I'm wondering if you guys have any guidance for giving compliance teams evidence for which services they should be more likely to trust. Like, should there be an argument that some services are less trustworthy than others?
I think it's an everlasting struggle, right? Comfort versus security. You always want to do like next, finish and get it done with, but in the end of the day, sometimes it's a double-edged sword. I would say that managed services, as pointed out, is probably more vulnerable to these kind of things. But again, you can always tailor solutions to, like example, take a managed service, use it for most of your workloads, and extra sensitive workloads, just put them in custom machines.
Cool. Makes sense. Joel, hold on.
Yeah, I just wanted to ask quickly your point of, managed services are easier targets, and maybe I put the most sensitive ones on my own machines. But the benefit of a managed service is that maybe somebody who's better at security has built a managed service, and if I put it on my own machine, then I may also screw that up and make that a more vulnerable target. So, like, how do you think about that sort of trade-off and the balancing of the risks?
That's a fair point. I think that in this case, what we've seen is where people implement sandboxes, there's more space for errors and mistakes. And I think if you implement, like, instead of using the managed service and being in a sandbox, I think when you don't have a sandbox, you have less issues that might pop up. But it's a downside because you need to implement your own things, and it will take you more time. So sometimes it's best to just hope that the managed service is working as intended, and just hope that there are no security issues.
Actually, I have a little bit of additional input. If you look at the Azure Synapse Analytics service and its page, one of the properties they say is unmatched security. Now, it's kind of funny, but it's not really funny because most of the service really is at a high level. And when we talked to the developers themselves after fixing this problem, they were like, okay, we're putting it in ephemeral instances, and we're sandboxing everything and isolating. Okay, so now that we have alarmed them about this, now the service is a lot more secure. But I would say when you use managed services, just use the minimum amount of features that is still comfortable to you to use it.
Sure, 1 second, Zach.
Maybe a dangerous question, but do you think you found them all? Is this the tip of the iceberg?
Can you come again?
I'm wondering this is a dangerous question, but how common you think this might be? Of course, new services are being developed all the time, but do you think you found them all, or just the low-hanging fruit, or?
We definitely did not find them all. I don't think anyone can say that. It's with time, there's more code deployed, more changes, bugs can appear out of nowhere. It's very, very hard to say we found them all, and I don't think anyone can really say that at any point.